Have you ever walked into a room and forgotten why you went there? Read a page of a book and realized you remember none of it? Forgotten names, conversations, appointments, even while feeling mentally exhausted all the time? Most people assume memory decline is simply part of aging, stress, or having too much going on. But what if memory problems are often not a memory problem at all? What if they're actually a brain energy problem, a sleep problem, a stress problem, or even a metabolic problem? Here's what's really going on inside your body. Memory is not stored in one single place in the brain like files in a cabinet. Memory is a dynamic biological process involving attention, emotion, sleep quality, neurotransmitters, blood flow, inflammation, glucose regulation, and nervous system state. In other words, your ability to remember depends heavily on how well your brain and body are functioning together. And this is why so many people struggle with memory today. Chronic stress elevates cortisol. Poor sleep disrupts memory consolidation. Blood sugar instability reduces mental clarity. Constant dopamine stimulation fragments attention. Inflammation impairs neural signaling. And information overload prevents the brain from properly encoding experiences in the first place. So people think they have a bad memory, when often the brain simply never stored the information efficiently to begin with. Let me explain this with a simple analogy. Imagine trying to save files onto a computer while the battery is dying, dozens of tabs are open, the internet keeps disconnecting, and the hard drive is overheating. The issue is not storage capacity. The issue is system performance. That's exactly how memory works biologically. The brain requires stable energy, focused attention, quality sleep, emotional relevance, and proper recovery to encode and retrieve information effectively. And one of the most important structures involved in this process is the hippocampus. The hippocampus acts like a memory indexing system. It helps convert short-term experiences into long-term memories. But the hippocampus is highly sensitive to stress, sleep deprivation, inflammation, alcohol, and elevated cortisol. This is one reason chronic stress can make people feel mentally foggy or forgetful. The brain shifts resources towards survival instead of learning and memory formation. Now, the encouraging news is this: memory is highly trainable. Neuroplasticity, the brain's ability to rewire itself, continues throughout life. And what the research shows is that lifestyle factors like sleep optimization, exercise, focused learning, proper nutrition, stress regulation, and deliberate memory training can significantly improve cognitive function and memory performance at almost any age. Today, we're going to break this down step by step. We'll talk about how memory actually works inside the brain. We'll explore the effects of sleep, cortisol, dopamine, attention, and metabolism on memory formation. We'll discuss why emotional intensity improves recall. We'll cover science-based tools for improving learning speed and retention. And most importantly, we'll go through practical daily protocols that help strengthen memory naturally, without relying solely on stimulants or productivity hacks. Because once you understand the biology of memory, you stop blaming yourself for forgetting things, and you start optimizing the systems that allow the brain to remember in the first place. Here's what's really going on inside your body when you form a memory. Your brain is not recording reality like a camera. It's filtering reality, constantly deciding what matters enough to keep. And the single most important factor that determines whether something becomes a memory is attention. Attention is the gateway to memory. Without focused attention, the brain struggles to encode information deeply enough for later recall. This is why people often say, "I read the page, but I don't remember anything." Or, "I heard the conversation, but it didn't stick." In many cases, the issue is not memory capacity. The issue is fragmented attention. Let me explain this with a simple analogy. Imagine trying to write on wet cement while someone keeps shaking the ground every few seconds. The writing never fully settles. That's what constant distraction does to memory formation. The brain needs periods of stable focus for neural patterns to strengthen properly. But modern life constantly interrupts this process. Notifications, multitasking, social media, short-form content, background noise, emotional stress. All of these fragment attentional networks. And when attention becomes fragmented, memory becomes shallow. What the research shows is that task switching significantly reduces cognitive efficiency and weakens encoding quality. The brain pays a metabolic cost every time attention rapidly shifts. And over time, chronic overstimulation reduces the brain's ability to sustain deep focus. Now, this becomes especially important when we look at dopamine. Dopamine is often misunderstood as simply the pleasure chemical. But dopamine is heavily involved in motivation, attention, novelty detection, and memory encoding. When dopamine rises appropriately during focused learning, the brain essentially marks information as important. This strengthens neuroplasticity, but modern environments overload dopamine systems constantly. Rapid scrolling, constant novelty, endless stimulation. The brain becomes conditioned to seek quick rewards instead of sustained focus. And this lowers the ability to maintain attention long enough for deep memory formation. In simple terms, High stimulation weakens deep learning. This is one reason many people consume enormous amounts of content today, yet retain very little of it. The nervous system becomes optimized for scanning instead of remembering. Now, one of the most powerful tools for improving memory is reducing attentional fragmentation. A practical protocol looks like this: work or study in uninterrupted blocks of 60 to 90 minutes. Silence notifications, keep one task open, avoid multitasking completely, and ideally place the phone in another room. This allows the prefrontal cortex and hippocampus to work together more efficiently. Now, another major factor in memory formation is emotional intensity. Emotion tells the brain, this matters. This is why emotionally charged experiences are often remembered vividly for years. The amygdala, involved in emotional processing, interacts closely with memory systems during emotionally significant experiences. And importantly, this can be used intentionally for learning. When information becomes emotionally meaningful, visual, surprising, or personally relevant, retention improves dramatically. For example, instead of passively reading information, try teaching it aloud, visualizing it, connecting it to real-life examples, writing it by hand, explaining it to another person. These methods increase neural engagement, and active engagement creates stronger memory traces than passive exposure. Now, another powerful tool is deliberate recall. Most people repeatedly reread information, but memory improves more effectively through retrieval practice, meaning testing yourself, recalling information without looking, struggling slightly to remember. That effort strengthens neural pathways. Let me explain this with a simple analogy. Imagine walking through a forest. The first time the path is difficult, but every repeated walk strengthens the trail. Memory works similarly. The more often you retrieve information actively, the stronger and faster the neural pathway becomes. This is why flashcards, self-testing, summarizing from memory, and active recall are extremely effective learning tools. And importantly, spacing matters too. Short repeated exposures over multiple days usually outperform one long cramming session. The brain consolidates information better through spaced repetition because neural reinforcement occurs repeatedly over time. Now let's talk about stress. Short-term alertness can temporarily sharpen focus, but chronic cortisol elevation damages memory systems over time. High cortisol impairs hippocampal function while narrowing attentional flexibility. The brain becomes optimized for threat detection instead of learning. This is why people under chronic anxiety or burnout often experience forgetfulness and brain fog. Their nervous systems are prioritizing survival physiology. A very effective protocol for improving learning before studying or working is calming the nervous system first. Even 5 minutes of slow breathing before focused work can improve attention quality significantly. Because a regulated nervous system learns more efficiently than a chronically stressed one. If this is helpful so far, consider subscribing. I post content like this every day focused on neuroscience, metabolic health, learning, memory, and science-backed tools for optimizing the brain and body naturally. Because improving memory is not about forcing the brain harder. It's about creating the biological conditions that allow the brain to learn effectively in the first place. One of the most powerful and underestimated tools for improving memory is sleep. Because memory is not fully created while you're learning, a huge portion of memory formation happens afterward while you sleep. Here's what's really going on inside your body. During sleep, the brain doesn't simply shut down. It becomes highly active in organizing, strengthening, filtering, and storing information gathered throughout the day. In many ways, sleep acts like the brain's nightly editing and filing system. Experiences move from temporary storage into more stable long-term neural networks. And without sufficient sleep, this process becomes impaired. Let me explain this with a simple analogy. Imagine spending all day downloading important files onto a computer. But every night, before the files finish saving, the power shuts off. The next day, some information is incomplete, corrupted, or missing entirely. That's essentially what poor sleep does to memory consolidation. The brain may receive information during the day, but it struggles to stabilize and organize it properly afterward. And one of the most important structures involved here is the hippocampus. The hippocampus temporarily stores new experiences and information before transferring many of them into broader cortical networks during sleep. This transfer process is especially active during slow-wave deep sleep and REM sleep. Deep sleep helps stabilize factual learning and physical skill acquisition. REM sleep helps integrate emotional learning, creativity, pattern recognition, and associative thinking. Both are essential. This is why people often notice that problems seem clearer after sleeping on them. The brain literally reorganizes information during sleep. Now, what the research shows is that even partial sleep deprivation significantly reduces memory encoding, attention span, reaction time, and cognitive flexibility. In simple terms, a tired brain learns slower and remembers less. And importantly, sleep deprivation also elevates cortisol. High cortisol disrupts hippocampal function and impairs neuroplasticity. So poor sleep damages memory both directly and indirectly. This is one reason chronic stress and poor sleep create such a powerful negative cycle. Stress reduces sleep quality, poor sleep increases cortisol, elevated cortisol impairs learning and emotional regulation, then cognitive fatigue increases stress even further. Now let's make this practical. One of the most effective ways to improve memory is optimizing sleep timing consistently. The nervous system loves rhythm. Going to sleep and waking at relatively consistent times strengthens circadian biology and improves sleep architecture. Even small improvements in sleep consistency often improve focus and recall dramatically within days. Another critical factor is morning sunlight exposure. Getting natural light into the eyes within the first 30 to 60 minutes after waking helps anchor circadian rhythms and improves nighttime melatonin release later. This strengthens sleep quality naturally. A simple protocol: 5 to 15 minutes of outdoor light in bright conditions. Longer if cloudy, no sunglasses if possible. This single habit improves sleep, mood, alertness, and memory performance simultaneously. Now, another major issue affecting memory today is late-night overstimulation. Bright screens, heavy meals, social media, stressful content, late caffeine, alcohol. All of these impair sleep quality and memory consolidation. Alcohol is especially important to discuss here. Many people assume alcohol helps sleep because it causes drowsiness. But physiologically, alcohol fragments sleep architecture and suppresses REM sleep significantly. This weakens memory consolidation and emotional processing. Even moderate alcohol intake can impair next-day cognitive performance and learning efficiency. Now let's talk about nutrition. The brain consumes enormous amounts of energy, and stable energy supply matters tremendously for memory. Blood sugar crashes impair attention and cognitive function rapidly. This is why highly processed high-sugar meals often create mental fatigue shortly afterward. The brain experiences unstable fuel delivery. A better approach is prioritizing meals that stabilize glucose, protein, fiber, healthy fats, mineral-rich whole foods. Examples include eggs with vegetables, salmon with olive oil and greens, Greek yogurt with berries and nuts, chicken with rice and avocado. These foods provide more stable metabolic support for the brain. Now, omega-3 fatty acids are also extremely important. The brain is highly lipid-rich tissue. DHA, a major omega-3 fat found in fatty fish, supports neuronal membrane function, synaptic signaling, and cognitive performance. Research continues to associate omega-3 intake with better brain health and cognitive aging outcomes. Hydration matters too. Even mild dehydration impairs concentration, reaction time, and memory performance. Many people feel mentally foggy simply because nervous system function is operating under physiological stress from inadequate hydration. Now, another extremely powerful memory tool is exercise. Exercise increases blood flow, oxygen delivery, insulin sensitivity, and brain-derived neurotrophic factor, BDNF, which acts almost like fertilizer for neural connections. What the research shows is that both aerobic exercise and resistance training improve neuroplasticity and cognitive function over time. Movement literally helps the brain learn better. A simple protocol: daily walking, 3 to 4 resistance training sessions weekly, Zone 2 cardio several times per week, and ideally some movement before intense learning sessions. Because physically active brains tend to be more adaptable brains. If this is helpful so far, consider subscribing. I post content like this every day focused on neuroscience, metabolic health, learning, longevity, and practical science-backed tools for optimizing the brain and body naturally. Because memory is not just about intelligence. It's about how well you support the biological systems that allow the brain to function at its highest level. One of the most fascinating things about memory is that the brain does not treat all memories equally. Some experiences disappear within minutes, while others stay with you for decades. And the difference often comes down to one factor: biological significance. Here's what's really going on inside your body. The brain is constantly asking, is this information important enough to spend energy storing? Because memory formation is metabolically expensive. Strengthening neural connections requires energy, neurotransmitters, sleep, blood flow, and protein synthesis. So the brain prioritizes information connected to survival, emotion, novelty, repetition, and meaning. This is why emotionally intense moments often feel unforgettable. Your wedding day, a major accident, a painful argument, a huge achievement. The brain tags emotionally significant experiences as important. And one of the key neurochemicals involved in this process is norepinephrine. Norepinephrine increases alertness and strengthens memory encoding during emotionally activated states. This is why moderate emotional intensity can actually improve learning and recall. But there's an important balance here. Too little emotional engagement creates weak encoding. Too much stress impairs memory formation entirely. This follows what neuroscientists often call an inverted U relationship. Moderate activation improves performance. Extreme stress reduces it. Let me explain this with a simple analogy. Imagine trying to sharpen a photograph. Too little contrast and the image looks blurry. Too much contrast and the image becomes distorted. The nervous system works similarly. Optimal memory requires enough activation for focus, but not so much stress that the brain shifts fully into survival mode. This is why chronic anxiety often damages learning efficiency. The brain becomes overly focused on threat detection instead of flexible thinking and memory formation. Now, another major factor here is novelty. The brain pays attention to change. New environments, unexpected information, unique experiences. Novelty increases dopamine and attentional engagement, which strengthens encoding. This is why traveling often creates vivid memories. The brain becomes highly alert because the environment is unfamiliar. You can use this principle intentionally during learning. For example, changing study locations occasionally, using visual diagrams, teaching concepts creatively, associating information with stories or unusual images. All of these increase novelty and improve recall. Now, another extremely powerful memory enhancer is visualization. The brain remembers images and spatial relationships far more efficiently than abstract information alone. This is why memory champions often use visual association techniques. They convert information into vivid mental imagery. For example, instead of trying to memorize random facts mechanically, you attach them to exaggerated visual stories. Because emotionally vivid and visually unusual experiences activate broader neural networks. And broader neural activation creates stronger memory traces. Another powerful method is linking new information to existing knowledge. The brain learns through association. New neural pathways connect more easily when attached to familiar frameworks. This is why analogies work so well. Instead of memorizing isolated data, the brain builds interconnected meaning. The more connections information has, the easier retrieval becomes later. Now let's talk about aging and memory. Many people assume cognitive decline is inevitable with age. But what the research increasingly shows is that lifestyle plays an enormous role in cognitive aging. Chronic inflammation, insulin resistance, poor sleep, sedentary behavior, social isolation, hypertension, ultra-processed diets. All of these accelerate cognitive decline and impair neuroplasticity. In contrast, brains exposed to movement, learning, social interaction, quality sleep, metabolic stability, and cognitive challenge remain more adaptable over time. One especially important factor is insulin sensitivity. The brain is highly dependent on efficient glucose metabolism. Some researchers even refer to Alzheimer's disease as type 3 diabetes because impaired insulin signaling strongly affects cognitive function. This is why metabolic health matters enormously for memory and longevity. A practical protocol for supporting long-term cognitive health includes stable blood sugar, regular exercise, adequate protein intake, omega-3 rich foods, quality sleep, stress regulation, continuous learning, and meaningful social connection. Social interaction itself is incredibly important for memory. Conversations, emotional engagement, storytelling, humor, and shared experiences activate complex neural networks. Isolation reduces cognitive stimulation dramatically. The brain thrives on meaningful engagement. Now, another highly underrated memory tool is boredom. Modern brains rarely experience true stillness. Constant stimulation weakens reflective processing and memory integration. Some of the brain's most important consolidation processes occur during quiet moments: walking, showering, resting, daydreaming, silence. This involves something called the default mode network, a brain network involved in internal reflection, memory integration, creativity, and self-processing. In simple terms, the brain needs periods of reduced input to organize information effectively. This is why many people suddenly remember ideas or solve problems during quiet moments rather than during intense stimulation. A practical protocol is intentionally creating small periods of low stimulation daily. No phone, no music, no multitasking, just quiet thinking or walking. These moments improve cognitive integration more than most people realize. And one final point here is critical. Memory improves when learning becomes identity-driven. When people believe, I am someone who learns, I am someone who remembers, I am improving cognitively. The brain approaches learning differently. Attention improves, consistency improves, motivation improves, and because neuroplasticity responds to repeated behavior, those identity shifts compound over time. Because ultimately memory is not fixed. It's dynamic, trainable, and deeply connected to the overall health and state of the brain and body. So when we step back and look at the bigger picture, one thing becomes very clear. Memory is not just about intelligence. It's about biology. It's about how well the brain is able to pay attention, process information, stabilize neural connections, recover during sleep, regulate stress, and maintain consistent energy supply. And once you understand that, you stop treating forgetfulness as a personal failure and start recognizing it as feedback from the nervous system. Today we talked about how attention acts as the gateway to memory formation, because the brain cannot deeply encode information it never fully focused on in the first place. We discussed how dopamine-driven overstimulation and constant multitasking weaken concentration and fragment learning. We explored how sleep acts as the brain's nightly memory consolidation system, strengthening neural pathways and organizing information into long-term storage. We covered the role of cortisol and chronic stress in impairing hippocampal function and reducing neuroplasticity. And we talked about how stable blood sugar, movement, hydration, omega-3 fats, sunlight exposure, and metabolic health all directly influence cognitive performance and memory. These systems are deeply interconnected because the brain is not separate from the body. The brain is part of the body, and the health of one always influences the other. This is why memory optimization cannot rely only on brain hacks. You cannot out-supplement chronic sleep deprivation. You cannot out-caffeinate poor metabolic health, and you cannot build deep focus in an environment of constant overstimulation. Real cognitive performance comes from building the biological conditions that allow the brain to function properly. And the encouraging news is this: the brain remains adaptable throughout life. Neuroplasticity continues well into older age, meaning your ability to learn, focus, remember, and improve cognitively is far more trainable than most people realize. Small daily behaviors compound powerfully over time. Better sleep consistency, more sunlight, reduced digital overstimulation, focused work sessions, walking daily, resistance training, breathing practices, more whole foods, stable glucose, intentional learning, meaningful social interaction, quiet reflection. These habits strengthen not only memory, but overall brain resilience and long-term cognitive health. And one of the most important ideas from this entire discussion is this: memory improves when learning becomes active. The brain remembers what it uses. So instead of passively consuming information constantly, engage with it. Teach it. Write it. Visualize it. Recall it. Apply it. Struggle with it slightly. Because effort strengthens neural pathways, and repeated retrieval strengthens them even more. Now here's my challenge for you. Choose just one memory-supporting habit from this video and implement it consistently for the next 7 days. Maybe it's sleeping an extra hour. Maybe it's taking a walk before studying. Maybe it's eliminating distractions during focused work. Maybe it's practicing active recall instead of rereading notes. Start small, but pay attention to how your brain responds. Notice your focus, your recall, your mental clarity, your emotional energy, because often when people improve memory, they're actually improving the health of the entire nervous system. And that affects everything: focus, mood, productivity, longevity, creativity, learning speed, and quality of life. If this video added value, like the video and subscribe to join others optimizing their brain, metabolism, nervous system, and long-term health naturally through science-backed tools and practical neuroscience. And as always, thank you for watching.